On Wednesday in class, I went over classification of compounds and acids, including ionic compounds, molecular compounds, binary acids, and ternary oxyacids. In the previous video lecture for this chapter, I went over monoatomic and polyatomic ions and naming them, including cations, anions, and oxyanions. In this video chapter, I will go over writing chemical formula of a compound and naming them. Formulas of ionic compounds. If the ions in the ionic compounds have the same charge, the formula unit contains one of each ion. For example, when potassium and bromide combine to form potassium bromide, one potassium and one bromide because they have the same charge, +1, -1. The opposite charge. Another example of calcium and oxide. When calcium ion combine with oxide ion, will form calcium oxide CaO, one calcium and one oxygen, because the charge on calcium is 2 plus and the charge on oxygen is 2 minus. However, if the charges of ions are not equal, we must balance the positive and negative charges by increasing numbers of atoms. For example, when barium 2 plus combined with chloride ion, you need 2 chloride ions for the chemical formulas, because the barium has 2 plus charge, whereas chloride ion has only -1 charge. So you need 2 chloride ions for each barium, or for one barium 2 plus ion. Another example is lithium ion combined with sulfide ion, because sulfide ion has 2 minus charge. So you need 2 lithium ions, which each lithium ion has +1 charge to form Li2S. You can use a crossover rule that will make it easier to write a chemical formula of a compound. You can see that the chemical formula is written correctly by crossing over the charge on each ion. For example, here in the case for aluminum oxide, the charge on aluminum ion becomes the subscript on oxide ion, and the charge on oxide ion becomes the subscript on the aluminum ion. Next, we learn of writing the chemical formulas of ternary ionic compound. In the previous slide was the example of a binary ionic compound because it contains only 2 elements, aluminum and oxygen. First, if the charges are equal, you can use the same rules of binary ionic compound. The formula will have one of each ion. For example, magnesium sulfate, because magnesium ion has 2 plus charge and sulfate ion has 2 minus charge. See the charge equal, the opposite, you only need one of it to form MgSO4. Note that this is a ternary ionic compound because you have 3 elements in here, oxygen, sulfur, and magnesium. Now, if the charges are not equal, you must use the crossover rule to make the total charge equal 0. If you have more than one polyatomic ion, it's displayed in the parentheses. Here, example, ammonium ion, sulfate ion, both of them are polyatomic ion. So you have to put the polyatomic ion in a parenthesis. Then you use a crossover rule to determine the subscript. SO4 has 2 minus charge, so it becomes the subscript on ammonium ion, and +1 charge on ammonium ion becomes the subscript on SO4 sulfate. Now, because +1, that means 1, you can omit it on sulfate. You can determine the charge of ion in a binary ionic compound. If an ionic compound contains a metal that can have more than one ionic charge, we can determine the charge on the ion. Because the sum total charge on an ionic compound must equal 0. For example, what is the charge on the chromium ion in Cr3n2? The charge on the nitrogen ion is always 3 minus nitrogen here. So we have a total of 6 negative charge. So 2 multiplied by 3 for each 3 minus for each nitrogen, that's 6 negative charge. The sum of the charge on the chromium ion must be positive because we follow the rule that the sum total charge of an ionic compound must equal 0. If the negative is 6, the positive must be 6. So if we call X is the charge for each chromium ion, there are 3 chromium ions and it's a total of 6 positive, so each chromium has 2 plus. Now we go over the naming ionic compounds. We talk about naming monoatomic anions, naming monoatomic cations. I talk about binary ionic compounds. Now we talk about how to name them. When naming ionic compounds, we combine the cation and anion name and to drop the word ions. So with the cation name first and the anion name second. For example, MgO is composed of 1 magnesium ion and 1 oxide ion. Therefore, the name is magnesium oxide with a drop ion for both magnesium and oxide. Now, what is the name of cinnabar? HES. Mercury is He2 plus, 2 ion, and sulfide 2 minus is a sulfide ion, so the name is mercury 2 sulfide. You can predict a formula for binary ionic compounds from its name. For example, what is the formula of iron 3 fluoride? So you're given the name here, iron 3 fluoride. You can predict the formula. We know that iron 3 means iron 3 plus that have plus 3 charge. Fluoride, we know it's always have minus 1 charge. Since the total charge must equal 0, the formula for iron 3 fluoride is Fe F3. Each Fe, which ion have plus 3 charge, and the 3 fluoride ion, each fluoride have minus 1 multiplied by 3, that is minus 3 plus 3 equals 0. Next is a naming ternary ionic compound. I talk about names of polyatomic anions and names of polyatomic cation in my previous video lecture, and in class I talk about ternary ionic compound. Now we talk about names of these compounds. This table is in your textbook. It shows names of common polyatomic ions, include name of polyatomic cation ammonium ion and other names for polyatomic anions. So how you name them? We name the ternary ionic compound like binary ionic compound. You start with a cation name followed by the anion name. For example, KCl2 is named potassium chloride because K is potassium, ClO2 is chloride ion. If we have a metal that can have more than one oxidation state, we have to determine the charge on the metal. For example, ClO3 in the parenthesis 3 times is composed of cobalt 3 and chloride ion. So it's named cobalt 3 chloride. Now, NO3 is a polyatomic ion, so don't separate N from O and name them separate. That is incorrect. So you have to name it as a nitrate. You can predict the formula for binary ionic compounds based on the formula of a similar compounds. For example, what is the formula of cesium nitride, given that sodium nitride is NaNO2? You know that cesium and sodium, Na, they are both in group 1 and will have the same ionic charge. Therefore, the formula for cesium nitride is CnO2. So here sodium and cesium, they are the same group on the periodic table. So you can name them similarly. So next, let's go over molecular compound and naming them. Recall that a binary molecular compounds, they are composed of 2 non-metals elements. And a molecule is the simplest representative particle of a binary molecular compound. IUPAC has set the following order for writing the elements in a binary molecular compound: CP, NH, SI, BR, CL, O, and F. What does it mean? If you have a compound contain hydrogen and bromine, you have to start with hydrogen first and bromine later. You cannot put bromine first. So you have to write HPR and BHRA. That's what really is mean. So how you name the binary molecular compounds? The first element in the compound is named first, and then the second element has a suffix IDE. Now the number atom of each element must be indicated by the Greek prefixes. The prefixes are not used in naming ionic compounds. If the one atom, you use mono. If there's two atoms, you use di. 3 atoms, you use tri, and so on. So let's look at one example. What is the name of the molecular compound P4S3? Since there are 4 phosphorus atoms, you use tetra because tetra means 4. There are 3 sulfur atoms, so you try for sulfur. So the name of P4S3 is tetra phosphorus trisulfide. How about the name for P4S7? Now you know that you see it here, the 4 phosphorus, so 4, you have to use tetra phosphorus. The 7 sulfide, because 7 is hepta, so you write heptasulfide. So the name is tetra phosphorus heptasulfide. There's an exception, only an exception. Is to use the Greek prefix when naming binary molecular compound that have only one atom of the first element. The mono is not used. However, the prefix mono is only used for the second element. For example, CO carbon monoxide. The prefix for carbon mono is dra. For xenon acid, the prefix mono for xenon is dra in this chemical formula. Now next, binary acid. Binary acid is an aqueous solution compound that contains hydrogen and a non-metal. We've seen it before. Hydrochloric acid, hydrobromic acid, hydrofluoric acid. But the binary acids are named using the prefix hydro before the element stem and adding the suffix it for the acid, like I just said, hydrofluoric acid or hydroiodic acid or hydrochloric acid, as I show us up here. Now, how about ternary oxy acid? Ternary acids are aqueous solution of a compound that contains hydrogen and an oxygen ion. If the acid is derived from an oxygen ion ending with 8, the suffix change to IC acid or it acid. For example, HNO3 is a nitric acid from the nitric ion. Remember, I talked in my video lecture of NO3 is a nitric ion. If the acid is derived from an oxygen ion ending with ITE, the suffix is changed to OUS acid. For example, NO2 is no nitrous acid because NO2 minus is nitrite ion. Here's a list of names of oxyanion and oxy acid. So you can see ternary oxy acid for when chloride ion combined with oxygen and hydrogen, or the ternary compound such as sodium NaClO, which is sodium hypochlorite, or NaClO2, which is sodium chloride. It's based on the polyatomic anions. So you can also can find this in your textbook. This will end up the writing chemical formula and naming ionic and molecular compound video.